The electromagnetic pipe and cable locating instrument works on the same principle no matter who makes that instrument. Plus, the instrument works in the exact same manner no matter what buried utility is being located. Staking University's glossary of terms is the foundation for a common locating language. Why is a common locating language needed? Since all of the instruments work on common principles, it makes sense a common language can be useful in training people how an instrument works and how to use an instrument. It can be very confusing to learn a process as complicated as locating without the benefit of a common language. In addition, a common language, one written in easy-to-understand terms, is very useful in establishing an awareness of locating issues among those that do not actually locate but are impacted by the results of locating. Our 109 terms, plus 3 new terms that we're introducing in this introduction, are ways in which we communicate with people so they can understand in a simple way how the machine works, and secondly, how to use the machine. Because so much of locating cannot be seen, the words that are used to describe the locating process must help people visualize what they cannot see. With regards to understanding the locating process, classroom training provides a certain level of student comprehension.
Very rarely will you take a locate that you can't get, turn up the voltage, and all of a sudden get it. You're more dependent on frequency, firing grounds, insulation, and Mother Earth type, which is soil type and moisture content. Those are the factors that dictate current.
Hands-on training usually complements classroom training very well, as a lot of people are hands-on learners.
The needle's now in the center, which says both antennas see the same amount of signal. Now as he moves it that direction, B now sees more than A, so the needle's pointing to B.
The results of classroom and hands-on training are enhanced when a common language is used for both. These are just the simple definitions. What was needed in this project was to go beyond the simple definitions and expand them so that people could fully understand the terminology. Still, there are times when printed material, slides, animations, or videos are necessary in order to get people to see what they normally cannot see.
Flowing current on the line produces a magnetic field which wants to leave the line equally in all directions. The user detects a signal circle at the ground, then confirms he is not detecting the pumpkin-shaped field emitted from the transmitter.
There's also a real benefit of keeping concepts simple. Such is the case with terms such as pumpkin-shaped field, magnetic fields, and not round field. Part of what we're going to do in this introduction is define 3 new terms. We're going to define gain, bleed off, and two-man sweep. They don't appear in the language of locating. Gain, sometimes called sensitivity, is really like a zoom lens of a camera. We can zoom in or zoom out to see what we need to see. In locating instruments, the gain control can either be done automatically or manually. If it's done manually, then the operator of the instrument can zoom in order to see things that were tough to see before. Or, if the operator sees too much, can zoom out to narrow the focus of the equipment. Gain does not change the results of the locate. We don't change the results of the locate with the receiver. Different transmitter frequencies can and sometimes will do different things. There are 4 transmitter frequency ranges: low-low, high-low, low-high, and high-high. The transmitter's frequency setting is the primary cause of bleed-off through the soil. Here, the steel gas line is positioned in between a copper phone cable and an electric primary cable. The transmitter is connected to a nearby gas service and is transmitting both 480 kHz and 9 kHz onto the steel gas main. First, the results of 480 kHz. The gas line does not locate, but the phone and electric lines do. This is an example of extreme non-metal to metal bleed-off. Next, the receiver is switched to pick up 9 kHz. Only the steel gas line locates. There is no bleed-off to the phone or electric lines. Non-metal to metal bleed-off typically occurs with higher transmitter frequencies, but it doesn't mean it can't happen with lower transmitter frequencies. Here's an example of a more typical bleed-off scenario. Signal leaves the electric line and bleeds onto the adjacent cable TV line. Since the electric line and the cable TV line are grounded together, this bleed-off may be occurring because of the common grounding. Sometimes it isn't easy to determine whether bleed-off is metal to metal or non-metal to metal. But it's also possible that both kinds of bleed-off are occurring at once. The purpose of a two-man sweep is to inductively locate one or multiple buried targets. Two lines are detected during this two-man sweep. The purpose of the two-man sweep is to place the transmitter directly above any line found during the sweep. Once the transmitter is atop the line, the locate continues in normal fashion with the receiver. For best training results, it is recommended that Locating Unlimited, the language of locating, be used alongside with our original video training product, Locating Unlimited, and our Locating Unlimited editions of Underground Focus magazine.